Founder of the Spokane Cyber Cup, and we are going to be looking at the Blockchain Apprentice Challenge. This is written by Kevin Choi, a really awesome engineer who I used to work with at Security Innovation. So, as always, we're going to start with the prompt. You're an investigator in a string of recent blockchain hacks. One of your current investigations involves an NFT artist who appears to be laundering stolen cryptocurrency through suspicious NFT transactions. Gasp! For those who don't know, NFT stands for non-fungible tokens, and they're commonly used for images. If you've ever seen these, like NFT, monkey, for instance. Like NFT a lot of times is like pictures. When it says non-fungible, it's like a contract. So like a deed to your house is non-fungible because it's unique, versus like a dollar, which is fungible because $1 is same as $1, while one image or one picture or one contract is different than the other. You get your first big break in the case. Let's go. You have reason to believe that the NFT artist under investigation owns the wallet address CA5CC on the Sepolia testnet. So there's a lot to break down there. First, we have this address. An address is just a identifier for a user. It has some cryptographic properties. So if you've ever seen like public and private key cryptography, a lot of cryptocurrency stuff is really just fancy cryptography, and the address has to do with the public key of the user's private key. It's like hashed and take the first 20 bytes, something like that. So the address, all you really need to know though, is an identifier that of an account or a smart contract, which a smart contract is just code that's executed on the blockchain. And here we have Sepolia testnet. In blockchain, we have different network types. And one of them is like the production one, which we call mainnet, which you'll see here. And then we have testnets. And there are different testnets for Ethereum. And one of them is called the Sepolia. So we take a look at the artist testnet transactions and see if the artist has made any mistakes, which may reveal the artist's identity on mainnet. Once the artist identity is revealed on mainnet, we can publicly tag their wallet address, freeze their assets, and ensure no one else falls victim to them. So our objective here is to reveal one of the malicious NFT artist wallet addresses on mainnet. Hint 1, Etherscan is a great way to start exploring both transactions on mainnet as well as testnets. Data hosted on testnets may not be the same level of sanitation as data hosted on mainnet. I think that's the key to this challenge. I may change the prompt a little bit before you see this, but it'll be pretty similar still. So, we have this address, which is the owner of a wallet that we can look at, and we're going to look on Etherscan. So I have it pulled up here, and we can literally just do Sepolia testnet. And we can see here, Etherscan is a way for us to view transactions and contracts and accounts on the blockchain. And notice here how it's Sepolia.etherscan because we're on the testnet, versus mainnet, it would just be Etherscan. So we go here and we look up this address, which is what I also showed there. We can see the transactions that it's been working with. We can see safe mint, and the mint function is used to create NFTs. And we can see a transfer and a transfer from this address, which is probably transferring some NFTs. And then we have this 60806040. And that is actually the deployment of a contract. You can see here that it's the create opcode is showing, which tells us the contract has been created. Now, one way you can get to the bottom of this is, first, we're trying to find some information about this user. And if we look at this contract that was made, it's an NFT. And it's actually the Spokane Cyber Cup NFT. So I thought that was super cool that Kevin added that little rendition here. And if we look at the NFT itself, we can see Spokane Cyber Cup is the name, and then CTF is the symbol. But interestingly enough, with the base URI, we see this URL. With NFTs, you don't want to store the actual image on chain. So you store in IPFS, which is a decentralized storage mechanism. So we can copy this URL, look at the browser, and I haven't tested this, but I believe we can also just go to this NFT. So with this we call it SafeMint, and this has to do with the NFT that we're dealing with. Now I think I can actually just click on this NFT here, and if I click on that NFT, it's not showing exactly what I wanted. Okay, that's fine. Another way you definitely could do this is if you go to the NFT contract. You can actually run read-only calls within this if you'd like. And one of these is going to be the get URI function, the token URI, which was, we need to do token ID 0, I believe. We're going to use token ID 1. Well, that's great. I don't know why this isn't working, but and yeah, so that token URI is there. It's a string, and if we go to this string, we get this information. And it just says Mona Lisa needs no instruction, but it has a link to another image, and this image has Spokane Cyber Cup blockchain Apprentice, which I think is super cool. So now we can go further on this, and if we look at one of the hints, it says data in testnets may not be the same sanitization level as host on mainnet. So what would have an artist forgot to remove? And if we download this image, which I already have, we can look at some of the properties of this. I'm on Mac, but you can do similar things as in other spots as well. And if I click this, if I open up the image and I click I, it starts to show us different information. We can see the file name, color information, we can see the EXIF data, and the EXIF information, we can see this thing that says camera owner name. And this owner name appears to be an address. Addresses are usually, I think, 20 bytes long, or it's hex. No, it's not hex. It's 20 bytes long. So this could be interesting for us of like, why is this here? So I'm going to copy that, and I'm going to go back to Firefox. Now, if we look up this address and we just search it in Google, we'll notice that it brings us up in Etherscan, and they have 5,200 ETH, which is a lot of money. If we go to this address, we can see that this address has been doing a lot of different things. However, this is not the solution to it. If we look at the actual solution, we can see that important. Notice that the owner is this is the owner of the NFT, not the creator. It's very explicit in the prompt that we need to reveal one of the malicious NFT artist wallet addresses on mainnet. The owner of this is the only one that'd be able to, or the owner of the NFT is what we're looking for. I might make that more clear. So we can see that they own this Polynex Hacker 15. They're making a call to that. So I think this is the NFT, and we could probably just go to that contract. Nope. Oh no, it's two. Maybe look at NFT transfers. Okay, cool. So we have an NFT transfer to this Polynex Hacker, and we can see what this actually is. So if we go to this, we can look at the contract address, and now that we have the contract address of the NFT itself, we can figure out who deployed it. And if we go here, we can see that this came from the fake phishing 276033, and this has the address 3623. Now, this is actually the flag. So at this point, we saw an owner of the NFT, but we call that a sybil. wallet, where that's not what they're actually using, but they're spreading their assets between a bunch of different things. But we want to find where everything originated from. So this origination point is from the user who created the NFT, which in this case is going to be this guy. This challenge is a little bit weird if you're not experienced with blockchain. So if you have troubles with this, feel free to ask questions. Send us to coaches. There's a couple people who I think will be pretty familiar with this. So thanks for attending, and let me know if you have any questions.